All right, everybody, we're going to start. If you can come to your seats, we're doing the next session, openBIM workflows. I'm hungry too. My stomach is growling. I totally get it. So grab something. Again, thank you, Kyle, for keeping us all fed. Lots of coffee. Great. Look at how fast that was. I am very proud of you. So are we ready online too, Janice? Okay, good. Again, all right, session 2. So how many people thought the first session was really intriguing, really interesting, and maybe learned something? I expect every hand to go up. That was a trick question. Okay. All right, well, in this session, we're going to talk about openBIM workflows. And lately I've been using AI, just here or there. So I said, hey, AI, what is this? openBIM workflows. So here's what I got. And I think it's pretty close. It's a structured approach to BIM that enhances collaboration, data sharing, and interoperability. Who doesn't like all those words? I'm a middle child, so I really do. Across platforms and stakeholders. So isn't that pretty cool? Like what we're trying to do, right? Bring people together. So in this session, Ian's gonna lead us off, and he's got 2 slots. And then Will, you get to come up here again. Yay. Scott, I think, is on virtually, just making sure I know. And then we have Ian and Tony, which you heard, he sounded like God helping us out there. And then we're gonna do a Q&A interactive session, as well as then we're gonna bring Autodesk in. So don't let me forget that, because they have 5 minutes to talk about what they're doing. And then we have lunch, and lunch is out in the rotunda. Again, thank you, Kyle. Really great to have that, us to go outside and kind of hang out in the sunny California sunshine. So I'm going to introduce Ian Howell, who is the director of the Building Smart USA chapter. Thank you, Ian. And he's got a great sense of humor, by the way.
Tricia, thank you. So my history with Building Smart goes back to being one of the founding members way too many years ago to count. I do have the honor of being a Building Smart Fellow for people who spend more than 10 years working with Building Smart International and making a contribution. That's what the Fellowship Award recognizes. And I'm the immediate past chair of Building Smart International. About 4 years ago, I helped restart the US chapter, and I'm thrilled to have you all here today and to see the progress we've made in that short time. And the real restart for Building Smart USA was the addition of infrastructure, road, bridge, tunnel, rail, to what was previously understood, at least in the US, as being a standard for vertical buildings, for vertical construction. But with the inclusion of all of the elements and definitions and semantics for road and rail and bridge, there's been an opportunity to really coordinate with the timing of AASHTO and the state DOTs adopting 3D BIM modeling, which we're going to talk about just in a moment. First thing I'm going to do is switch the agenda. I'm sorry, Trish. I have 2 presentations back to back, but I wanted to talk about the open standards just as a general overview first, and then finish up with the workflows before we have Will Holmes give us some case study examples. So this is about open data standards. And that's really about making agreements. We see this everywhere in the world, and we know exactly what to do. There's an agreement. When it's red, we stop. When it's green, we go. And when it's yellow, we go faster before it turns to red. But it gives predictability, it gives consistency, and it is a standard built out of necessity. Do we have anyone from Ohio in the room? Congratulations. According to Copilot, Ohio were the first people to use the 3-color traffic signals in the US out of necessity born from the invention or adoption of technology. Horses did not need red, green, and yellow traffic lights. But the horseless carriage introduced the variable of speed, and suddenly there was a requirement where there were collisions, there was confusion, And specifically, the quotation there is about that local automobile clubs had established their own systems. We heard Will talk about we're all the same, but we have 50 different ways of doing things. That's a problem. By adopting a single method, there's consistency and many, many advantages. Some of those advantages of standards are predictability of behavior, consistency, the ability to collaborate. We can share information that is meaningful both to the sender and the receiver. There's some reliability about the integrity of the data. So standards are often born of necessity, per the example we've just seen. But as an industry, we're on a journey to really transform to digital project delivery, digital as-builts, asset management lifecycle systems that require data to be shared through the project lifecycle. So as we're on a journey for digital transformation, we've got to make the new standards that allow us to be efficient. We were all fine with 2D drafting standards. We were all happily drawing pen on paper, publishing sets of documents, being able to review them, redline them, wet signature. We had a set of standards for 2D drafting. Then along came CAD, and we had to rethink and revisit what does that new technology require that we're not doing today, because our documents are now electronic files. They're PDFs. They're being shared digitally. They're being viewed on computer screens. All required CAD standards that didn't exist in the world of 2D drafting. Now, of course, we have a new challenge because AASHTO, with its resolution to adopt 3D modeling, what's the standard for different ways of expressing geometry, how to associate properties and values to those objects and elements that are in the model in a way that they can be shared, in a way that there's consistency, predictability, to facilitate collaboration. All of those benefits of standards are needed for 3D modeling and the adoption of BIM. But there's a problem. There are a lot of software applications that can help author models. This is actually work that was done by the Auckland Airport. And at the top of the screen are all of the different systems that the consultants working for the airport were using. Every consultant wanted to use a tool that they were familiar with that was best in class, whether it was for structural design, space layout, all the things that were needed to do airside and landside and people navigation for the airport. Then, of course, there were additional tools that, as the owner, Auckland Airport were using themselves. And then there was a third set of tools down the bottom, which were all about how do you view and access information. So the problem becomes there are so many tools, each of which have their own data format, typically proprietary, and that didn't really help the airport in its mission to try and come up with a master plan. The oldest terminal was using software that was years old. The newer terminals were using building information modeling. What was needed was a common understanding, a common language. How do you bring all that information together so that it's meaningful for the owner and can be aggregated, analyzed, and have longevity? And they chose a path of open standards. So this is a use case, as it were, where open standards were able to solve a problem across, you can see there, 100 disparate models, 250,000 elements that were otherwise, sure, a lot of information about the project, but it wasn't structured information. It wasn't structured in a way that it could be used consistently, predictably, analyzed, and support asset management. So this is the version of the slide that Trish didn't show you, which is really complex. This is what we do. In all of this process of project delivery and asset lifecycle management, we've got many, many, many levels of detail. We've got all kinds of work processes. We've got different stakeholders that need to, just like at the Auckland Airport, share consistent, reliable information. And as we look at each part of this, we can imagine to manage that complexity, again, standards come from necessity. Building Smart, as you've heard from Aidan, stepped up to try and solve the puzzle where leaders of industry came together and said, okay, we do need to have some kind of data structure that we can be better at managing all that complexity. And that has subsequently become the IFC standard, but it really is just a bunch of agreements. Building Smart became the organization, consensus-based, where international industry leaders would come into the rooms, as Aidan described, which we now call domains, to make agreements on a common understanding for structured data. Initially, it was wall stores and windows for buildings, and then it obviously expanded to the infrastructure elements, pavement, canvas, and so forth, alignments for infrastructure. That work continues, and this is a slide that Aidan's already shown you, where we continue to meet. You've seen all of the examples of the summits, where we come together twice a year, typically spring and fall, to meet in rooms. A lot of virtual work in between. But the good news is that the US is now a voice at influencing this mission for Building Smart. 26 people attending the summit, a couple of representatives on the domain for infrastructure and the steering committee, and a lot of technical feedback from the work that's being done by the various pilot projects here in the US. And Building Smart didn't just do this for one segment of the industry, but it recognized that there were common elements across all these segments. Alignment's important for road, it's important for rail. So there's a harmonization where, okay, our architecture, engineering, and construction professionals are doing all kinds of building and infrastructure projects. Let's look at the common denominators across all of those different domains and capture them in one international set of agreements, which is industry foundation classes. And Will pointed out quite correctly that the win for AASHTO here is that you automatically inherit everything that's gone before. All the agreements that were made 5 and 6 years ago, 3 and 4 years ago, on what a road pavement definition should be. What's the relationship of a curb to a rail? What about the rules for guide rails? All of these things have been discussed and agreed with Finnish Transport Agency, Trafikverket in Sweden, Swiss Rail, Austroads in Australia, and importantly now also AASHTO representatives from the USA. So data standards give us a whole nother layer of benefits to the ones that I pointed out earlier. It isn't just about consistency and predictability. The key word here for me is this word interoperability. In fact, Building Smart started as the Industry Alliance for Interoperability, but try and translate that into 50 different languages. Kind of didn't work. So the term Building Smart and Building Smart International grew from that idea that industry needed to sit in a room and agree some common understandings that would facilitate efficiency, productivity, sustainability. But it wasn't about creating a book on a shelf. The vision from Building Smart was never to just publish a document and call it a standard of best practices or a guideline. It was about how do we actually get these agreements in use by industry. And that meant we partnered with the software companies because it was really delivery of what I call the last mile. So how do you embed the standard? How do you embed all those agreements in actual software, in this case, BIM authoring tools, BIM analysis tools, so that they can, in fact, be realized by users worldwide? And the fantastic news is that we've got incredible support from, I don't know, Aidan, probably almost 200 vendors worldwide or more. A couple of the largest vendors that we all know because they are global providers. This is Keith Bentley from Bentley Systems. The only real approach to making an industry-wide transformation is for people to organize around things that are open. And obviously Building Smart is big on things that are open. Open standards for use by all, openly shared, open data exchanges. Andrew from Autodesk. Again, this idea of an interoperable ecosystem. Our products need to work with other products because Auckland Airport could have solved its problem a different way. It could have said, we're all using one brand of software. Our consistency is going to come from limiting ourselves to one particular application or some few choice applications, which, by the way, is how British Airports Authority did Terminal 5 at Heathrow. But that doesn't give you the best tool of choice, where indeed open standards can allow you to use tools of choice, just as we saw at Auckland, and just as you would want in your state DOTs for your design software, for your analysis, for your asset management, but to share the information on an open data structure basis. And I love this quote from Jack Dangermond. Do we support open standards? Any company is a damn fool if they don't support open standards. That's pretty blunt, right to the point. It's why we now have JSTAN at AASHTO. I'm seeing Trish smiling because AASHTO needs to embrace this idea of open data standards in a way that can support the entire industry. And it takes more than one. You know, we've talked a lot this morning already about IFC as sort of a foundational standard, a set of agreements, a data structure for our industry. But the reason that we have partnerships, and I noticed my slide's very out of date, Aidan, there's now 17 of these partners, no longer the few that I had in my files. This is how we get BIM data, modeling data, interconnected with GIS data. And in fact, there is a joint committee with Scott Simmons, who's the chief standards officer for OGC, working with Building Smart International, led by Jag Rinella and Mark Goldman on behalf of BSI, looking at how those interconnection of BIM and GIS data, because location is important to our industry. So how do we solve that problem better, given some of the new technology that's available? Where are we headed? Because this is, today we've really been talking about the challenge of building information modeling and sharing 3D model data, both graphic, geometric data, and non-graphic properties, values. But we all know that there's this next evolution coming. So before we've even done our work on BIM modeling, we're starting to imagine digital twins. So Aidan referenced IFC5, the next generation of the standard, which needs to evolve to support the next generation of technology, which is digital twin. And a digital twin, as we've defined in these reports that are available on the Building Smart website, is a system of systems. It's an interconnection of systems, transportation, utilities, infrastructure, power, communications, how the sensors actually capture data and share data across those boundaries. It's no longer about industry segments. It's about one dynamic system. And the standard needs to evolve to support that. And we can only achieve that true promise of digital twin, where open standards are indeed used across the board to allow that capability. And this is really important because at the end of the day, it is about managing the asset for its life cycle. It's the 30, 40, and 50 years of use of the data and being able to rely on the data that becomes really, really important. And the digital twin can both simulate and interact with that asset model for the life cycle. So just in terms of overview for standards, Janice, if we could come up. I want to dig in specifically on workflow, but certainly, hopefully that's just set the context as to how Building Smart got to where it is today and the need that standards need to keep evolving. So even though we've done a lot of work related to BIM adoption, we're seeing some fantastic examples in the pilot projects. I know PennDOT are going to share some of their ADCMS work, I'm sure. Alan's here to show you how it can be used in practice on a real bridge. That's all capitalizing on the work done so far, but there's a lot more work to be done as we imagine the next generation. And those things do have to go in parallel, just as Aidan described. Implementing what we have, but starting to design for the future is all part of the work to be done. So let's switch topics now to workflow. And you've already seen quite a lot of workflow, so I'm going to call this a back to basics section. You've seen a deep dive into the validation service, which is part of the workflow. Aidan stepped us through all of the components of the standards and services of the workflow, but let me just go back to basics because I know that it's really hard for non-building smart people to understand the building smart vocabulary. It's like we've got this world of acronyms where we throw IDM and IDS and every other thing at you, BSDD, UCM, and we think you all understand that, but sometimes we just need to go a little slower and just lock in some of those foundational concepts. So if you'll let me do that for the next 10 or so minutes. openBIM is all of the above. So the standards and services are what makes up the thing we call openBIM. For accessible data that endures over time and enables interoperability between all those fantastic software applications that are for sale and can be used. This is the workflow for openBIM, and I've included UCM at the front end because basically it all starts with a use case. What problem are you trying to solve? Is it that you want to have the information about the steel given to the fabricator so that it can be manufactured and delivered on site? Take that use case as a descriptor of a problem, an industry problem, a work process that needs to be solved. So those essentially are your needs. And we used to do that in a thing called an information delivery manual, which traditionally was a Word document that we would write up the work process to really describe the steps, as it were, to get from concept through schematic design, through detailed design, contract let, as constructed, and asset management. We now have a tool called IDS, which is to define requirements, and I'll step through each one of these separately in a moment. But what are the information requirements to support that work process? And then in the produce step, it's how do you model that? And how do you validate the model's accuracy and completeness? And then when you're actually collaborating with others, the BIM collaboration format, BCF, allows you to raise an issue and share it, because not only is there a lot of authoring systems, but I'm sure you also know there's a lot of CDE systems as well. I don't know of a project that uses one common data environment. My best count is 7, because everyone brought their own to the table. And suddenly you have to have a standard for collaborating across different common data environments, which is the open APIs at the end in terms of the deliver step. So let's drill down again. I think we've got IFC nailed. It's the foundational piece. It's an ISO standard, and it is the data schema, fancy name for the structured data agreements we've made for all of the different elements. So that's about around geometry, properties, relationships, definition, semantics, all captured in the IFC data schema. IDM is this description of all of the steps of a work process. So AASHTO has actually published an IDM, BIM for Bridges and Structures Pooled Fund. When was that, Will? 2 years ago? Published an IDM where there are, remind me, 19 exchanges, that have been identified? So far, we've covered one. So to the point that was made earlier, there's still a lot of work to do, but we're on the right path. And having done one, we've now got a lot of lessons learned on how we can be more efficient and productive to tackle others. And it's about identifying workflows. This is not the BIM for Bridges example. This happens to be an example from the project that Aidan referenced, the Fehmarn Tunnel between Denmark and Germany. So the point being, all of this scales. It scales to one of the largest projects in Europe. It's not just about a small local project in a county. The use case management service is an online service. So if you have that problem you're trying to solve, you could write it up in an ADM, or now what you can do rather than write it up as an IDM is you can go to the use case management service. You may find a template. You may find a library of existing use cases that you can leverage, because trust me, a lot of the problems we're trying to solve are the same problems that are being solved by all of these other road authorities in other countries. So this is an environment where we can share use cases, we can look at other people's work process, we can learn from them, we can adapt or modify, and use this as a library or use this as a creation tool. This is about documenting the use case and all of the information needs that you have around how you support that work process. We've talked to you about the Building Smart Data Dictionary. I call this the 80-20 rule. If you want to simply understand the dictionary, 80% of what you need is already in the commonly defined IFC standard internationally. But there's the other 20% that might be variable. It could be variable on a national basis. You may have a national standard where you want to extend the international standard to include national requirements. And then you can extend it even again for local requirements. So to Will's point, don't reinvent the international stuff. Don't reinvent the national stuff. But if you have a local requirement that you need to add, this is your way of extending IFC to include that requirement. And the good news about the Building Smart Data Dictionary is our software vendor partners aren't just incorporating IFC in their software, but they're adding Building Smart Data Dictionary plugins so you can access those libraries from within the tools. A lot of work being done by in the US in terms of the bridge glossary, and that's being put onto the Building Smart Data Dictionary service. So again, it's going to be there as a national piece available to you all through the software. And it's really a hierarchy of structured information where what's not in the international standard would be in the national dictionary, and what's not in the national dictionary, you can still add as an extension. IDS, the most used standard, I think Aidan quoted 5,000 users. This is a way of you saying that these are my exact information requirements for this project. This is the information I need from you, for example, the consulting engineer who's designing the bridge, that you are going to make available to the fabricator. It's an information delivery specification. It can be written in plain English, but that converts to codification, which can provide for automatic checking. There are about 40 different tools that allow you to write an information delivery specification just by using plain English to state your requirements. And at the back end, that becomes coded information for automated checking. Again, the pooled funds are coming up with IDS templates, so you don't all have to start from scratch. It's a template that you can use, replicate, modify if needed because of a particular circumstance, but a lot of the work is being done by the pooled funds so that the state DOTs don't all have to start from scratch in terms of some of the use cases we talked about. Design to fabrication, model as legal document. These are all the things I need. These are all information requirements I need for a deliverable called model as legal document that will then go to the contractor. And IDS can be checked to be sure that it's complete. Is it all there? Automated checking. Again, very efficient and really leveraging technology in a way that we haven't been able to do before. Validation service. This is a free online service, and Aidan talked us through this in quite some detail, but you are validating that you are following all of the rules that are in the standard. So you're validating the integrity of the data structures in your bridge model or your road model against the standard. And we're back to red and green, which is where we started. Red means it's got an error, and you can drill down, as Aidan showed us, to get a description of what that error is and what needs to be fixed in the model. Green, got it right. Gray, it's either not in the model or not in the software you're using. So that's really a null result. But this idea that we are now able to look at all over the world really gives us data that we can use to put onto the scorecard that Aidan described. And that's the scorecard that allows us to certify software to say, in all of these green areas, all of these functional parts, this software is working 99.7% of the time. We've never been able to provide that level of certification in terms of functionality before, and it's not based on a few test files, which is what we used to do. This is now based on all the models that are being validated across the Building Smart community with hundreds of thousands of results really underlying the scorecard that you have the reliability that that software is working correctly for that part of your modeling. So why are we doing all of this? Why are we following these workflows? Why are we supporting openBIM? It really is about the information that's being captured during design, updated during construction, and the completeness and the integrity of the information that allows Trish's asset management department, I'm obviously on a time crunch here, to really have what they need for the management of the asset over its life cycle. So you are owners of assets, you are owners of infrastructure assets that have long lifetimes that need to be maintained and functionally kept up to date. And the data that you are getting from the openBIM workflows is giving you that capability. So really fast, we want to be able to quantify this. Calvin talked you through this project. This is about quantification. How do you make the business case to your leadership? Which is exactly what Will said. We all have to advocate to leadership to do this, to make this investment. So the project that Calvin's leading is all about quantification of ROI so that you can make that business case. Will, Tricia here, we've got a technical committee. If you want to be involved, if you want to explore openBIM, there are ways to do that by contacting these chapter representatives. If you want to help make the standard, Alexa and Will are working with the steering committee in terms of international standards development. The chapter's about adopting and implementing the standard. PSI is about creating the standard. And there's enormous resources on our website that Janice maintains, webinars, publications, links to resources. So if you don't want to get involved on a hands-on basis, there's an awful lot you can find that'll help you. And of course, we all need to be ready to do this. So there's training and certification, which Tony's going to be talking about in just a moment. And with that, the hook will come out and I'm off the stage.
Will Holmes does not need an introduction, but I will say thank you, Will, for speaking again, and you have less time.
Okay. Well, that's a kindness to everybody in the audience. So I'll try to be quick. And some of this we've already hit on. Pardon me. Okay. So talking about use case, first and foremost, again, JSTAN in the United States is completely engaging in this effort to get to open standards and engaging Building Smart on a variety of levels. This is just another way to look at it and also understand JSTAN's not doing it by ourselves. The pooled funds are a critical part of this. Our industry partners, both in the software development as well as in the construction design community, are critical. So we're all working this puzzle together. Again, the pooled funds have done a lot of work towards this. They embrace the national standards and international standards. They're working with different external stakeholders. And again, we've done training and we're working through pilots, and that's paying off. So again, some are doing model as legal document. And this is out of date apparently. So Ian, I'm going to have to borrow from you. But again, there is this, and we have opportunities to leverage what other people have done hard work to create. So again, let's do that. Let's not pretend that we're going to start from scratch and figure this thing out. So here are some examples of how we've used openBIM in the United States. First of all, I think all three of these were presented at IHEAP a few weeks ago, where we have 3 different bridge efforts, 3 different engineering leads, and building those out. So again, we start with the engineer that's doing the design work. No longer should the DOT say you have to use this piece of software. Okay? We need to break free of that locked-in model. Number one, we're not necessarily getting the best because we've been using this software for 20 years, so we have to use it for another 20. No, we need to be open to what is the best software to solve this problem. Okay, so pick the software of your choice that fits the need. That data is exported out, given to the owner. The owner then advertises that, right? The contractor takes that data in through an open file. Again, they get to choose the software of their choice, or actually softwares that serve the needs, the purposes that they need, the problems they need to solve. Okay? It's at their discretion. Ultimately, when they finish and the inspections are complete, that final model or models would push back to the owner, which I really need another slide, that would then diffuse that throughout the data ecosystem that is our assets. Okay? Your guardrail is going to go in a separate place from your lights, which will go in a separate place from your pavement, which is a separate place from your bridge. The world doesn't end. Those assets need to continue to live, and we need to honor the information all the way through, including financial, all the way through the life of that asset. Okay, this is an example with Synchro, where the IFC model is being viewed and understood. This is using US BIM, same bridge, same data. Okay, different tool. We have that flexibility. This is using, it's Trimble, but what? Trimble Connects, thank you, Will. Trimble Connects, and now again, within that BIM model, you're seeing the detail that's actually designed out, all the rebar. And again, just dynamic use to where you can see auto labeling, et cetera. All of this stuff should just naturally be flowing through the different parts of the work process. And different perspectives, different software, same data. That's the critical thing. You don't have to use one and only one piece of software. Okay? So some key takeaways. We use the national standards to drive these efforts in the pooled fund, or in the states that were part of the pooled fund. We use 3 different design firms, a lot of different authoring pieces of software, but we got consistent IFC deliverables. Okay? While we're different states, we're still able to drive into an open standard. And we had the flexibility in construction to use the tool that fit that moment and need. So that information is feeding back again into AASHTO, into our openBIM community to try to drive change and innovation. I bring this up because as part of the ADCMS grants, Washington took on signs. Okay, noble effort. They were honest that it didn't work very well. Okay, well, we need some of those struggles, okay, because that informs us, and then that creates the opportunity where, as Alexa was talking about earlier, the IDSC can then look at a project to build out signage so that then we create that as part of the national or international standard that then every DOT can use. Okay. So props to them for taking on the fight and trying to figure it out and then bringing the lessons learned back to the community. Final thing, I've mentioned it before, mention it again. We're doing the asset operation handover to, again, define the use cases, to understand what it is we need to build into the standard to efficiently hand off from the construction world into the asset management world. And just to plug AI, that's an AI generated image. Okay. So we are using it. We need to know it's coming. We need to understand it and then be honest about it when we use it. Okay. So that's it. Short and sweet. And Will, if you'll stand up. Will actually co-authored this. I was just in a hurry and I forgot to say that, but thank you, Will.
And Janice, I'm sure someone will ask if the slides will be available. And usually you do that on the website and a video recording, correct? After a while, but they do some production work, make us look better. Okay, thanks. All right, Scott, are you out there?
I am. Hopefully you can
Yay,
hear me
Scott.
okay.
Yeah, we can hear you well, I think. Can everyone hear okay?
All
Good,
right.
thank you.
This is where I stall for time because sounds like the audio is working well. Screen sharing is not working so well. So I apologize for that.
Scott, let's get your presentation up too. Oh, do you have your presentation, Scott?
I do. I'm having some issues on my end with sharing. Seems to be a system permissions issue.
Okay, try again. Okay, Scott, can you try again?
I'm working on it. I think I have it. I think I'm closer.
We're all
Sorry.
watching you.
Watching me stumble and I guess in my defense, I did offer to test earlier in the morning, and we weren't quite able to connect the dots to make that work. All right, I'm going to try sharing again. That's the desktop that I want. Ah. It's a third time's the charm, hopefully. Oh, it's looking good.
We got you.
Thank goodness. Okay. Well, thank you, everybody, for bearing with me there. Thanks for accommodating me, joining you all remotely. I wish, of course, I was in person with you all in San Diego, but it's not really too bad here in Indiana. So I was already trending at about 15 minutes, and then based on some of what I've caught just now and earlier this morning, I think I can trim it down a little more from that. So when I get to parts that are duplicate, I will skip over them and hopefully have some little nuggets of originality in here. Okay. We're going to talk about model validation, verification, and certification. So in terms of an introduction, I'd like to start on maybe a little bit of a somber note. So last month, we lost a good friend and former coworker here in Indiana, Kevin Merrick. And Kevin was one of the most knowledgeable senior engineers that I ever worked with and a really important mentor to me in my early career. Some of the things I remember most are some of his quotes that really are life lessons. So I'd like to start there with one of his quotes. So we're talking a lot about models. One of the important things to keep in mind is no model is perfect, but most models are useful. So that's what I want to keep in mind during this part of the presentation. Specifically, try to demonstrate how validation, verification, and certification can make sure that a model is useful to the person that ends up receiving it. So we're going to start with model validation, and I'm going to reference back to a previous conference where Rick Bryce made a really nice analogy of thinking of this in terms of like a school assignment, maybe from an English class, and so I'm gonna pull from that again this time around. So we can think of model validation as the initial step, as the spell check of your assignment. So then the natural question is, if this is a spell check, what are we checking against? Well, of course, this is an openBIM summit. openBIM models use the IFC standard for open structured data, as Ian mentioned recently. I've specifically highlighted foundation here, right? Because that's important to remember. This is the foundation of the standard. And so model validation in my eyes is kind of that baseline foundational check against the ISO standard, right? We're not talking about anything specific for a region or a particular owner or a particular use case. This is really sort of the primary starting point. And of course, ask any engineer, especially a structural engineer, what happens when you try to build on top of a foundation that is maybe kind of slippery or soft. That's going to be a problem. Luckily, IFC as an ISO standard, as an international consensus, is a solid foundation that we can build upon. So I thought I would talk through a couple of examples here, and I'm going to use alignment geometry for my examples because that's most of what I did for 15 years as a designer. So here's an example of a rule that we could consider part of model validation. And again, this is model validation because it's part of the international agreements. So we could look at a rule specifically for horizontal alignments for the segments. Each of those segments has an attribute that talks about what type of geometry it is. And you can see here the accepted, the standardized list of options here, line, circular arc, and then clothoid and some other transition spirals. And, we would expect the majority of usage here in the United States to be horizontal segments that are either lines or circular arcs. Then, of course, with the occasional clothoid spiral. sounds like we've already touched on the validation service multiple times, so I won't take too much time revisiting that again, other than that, I guess to re-impress upon folks that this is a fantastic tool for doing this foundational model validation. And of course, we've heard about how this tool was utilized in some of the pilot projects. You can see here we've got a nice row of green check marks across the board. So that is that's obviously good to see. The other thing I thought I would mention specifically around vocabulary from Ian, he was talking about agreements. And so the second check from the left here, the normative IFC rules, part of that are implementer agreements. Again, that go back multiple years, if not decades. Okay, so now if we move on to the next step, get into model verification. So let's extend our analogy of a homework assignment. And so now this is when the teacher is checking checking what you submitted against what they asked for. You can think of this as the requirements of the rubric, or in terms of model verification, this could be seen as a set of rules. They're going to be graded on a pass-fail basis. So again, going back to alignment geometry, if we're going to be grading an assignment, we need a list of rules or things that the assignment needs to address. So here's something that could be part of this step of the model checking process. Basically stating that for a road that's exchanged in a model, it needs to have information about the design speed, and it needs to be captured in a specific part of the standard. And again, this is starting to get into use case management. In particular, this could be part of design checking of a alignment geometry design submittal. So the good news is, of course, that this is the sort of thing that lends itself very well to capturing as a part of an IDS specification, and then using one of those multiple hundreds of tools to check in an automated manner at scale. So that's good for this example. Of course, we have other examples that aren't quite as straightforward. And so if there are any other road designers in the audience, you may recognize this directly from the AASHTO Green Book. Right? So if we have a road that has a design speed of 35 miles an hour and it has a horizontal alignment segment that is a circular arc and the radius is 1,820 feet, then the super elevation rate needs to be at least 3.2%. So as I said, we're getting kind of complicated here. And this is going to require a different type of tool. Usually I see this in an Excel spreadsheet or series of Excel spreadsheets with a bunch of multi-arm V lookups going in a bunch of different directions. Or it may also just be a manual check. All right, so then part 3, model certification. This is where the writing assignment analogy starts to fall apart a bit. But the best I could come up with is this is when the teacher checks that you didn't cheat by claiming someone else's work as your own. And I'll steer entirely away from AI and large language models and any sort of what's currently going on, and we'll think of the olden times when I was doing English assignments. So in terms of model certification, we've got to first identify what is it that needs to be certified. And this could be multiple things, right? It could be the content of the model itself. It could be that we want to certify that something was actually prepared by a registered professional, sort of a, like a license number and the corresponding state board maybe that that person is registered with. We also have certification for the software tools, along with other certifications that I didn't list here, like the professional certifications and training and so on. So it feels like there's a lot here and this might be overwhelming, but I would say fear not. By and large, these are already solved problems. So I'll give an example here and won't spend too much time. But the key point here is that if we're talking about certificates, then that certificate needs to come from somebody, and that somebody needs to be trusted, right? So this particular example here is certificates for encrypting website data so that you can pass information back and forth without someone snooping on it in the middle. And we see this called a certificate authority. This is also similar if you're putting together a resume and maybe you need to list a degree or some other evidence of a professional certification for someone. And typically you not only list that certification, but you also list the school or the institution, right? And so in that case, the institution is functioning as the certificate authority. So I could see something similar being set up as well in terms of a certificate authority for openBIM models as well. If we get to the professional certification, again, we've got some examples from computer science and information technology that we can pull from here. This diagram shows a public-private key pair process, and so the sender is encrypting a message, and then if they have shared a public key with the receiver, then the receiver can decrypt that and get the information. So again, coming back to that certification, this could potentially be a mechanism for having trust in a digital signature or a professional certification, that the model that someone is receiving was actually reviewed, developed, and certified by a particular licensed professional that's registered with a particular state board or other certificate authority. Okay, coming into the home stretch, software certification. So here I wanted to, again, kind of draw an example to something that already exists, something that we already have. And this is more from the construction side. One of the ways that you could think about this is to think of software tools and software vendors or technology suppliers as suppliers. And like I said, we have this already in construction, suppliers of our materials, things like aggregates. So I've screen grabbed a little bit here from our certified aggregate producer program here in Indiana. And you can see right at the beginning, this procedure, this basically talks about what's required for an aggregate supplier to be considered certified and able to provide the supplies, the aggregate that you need. So let's say you're a general contractor in Indiana and you just won a nice construction project and you need some stone for subgrade treatment. So you probably have a good idea of what quarry you'd like to haul that stone out of. So all you have to do is go online, look up this list, and make sure that your quarry is on the list here. Pretty straightforward, right? So let's then say you're a designer and you know what software tool you'd like to use for authoring the models as well. You can just go online, look up your software tool, and make sure it doesn't have any of the red failing marks on the scorecard from any of the rules that were checked and didn't check out. Okay, and I listed this as Q&A. I think we're going to do that in a group towards the end. So lastly, just I guess my ugly mug and some information on how you can contact me if you so desire.
Thank you, Scott. Technology can be tricky. You did a really good job. And we're 3 minutes early on the schedule.
All right.
Thank you. All right. So Tony, you're out there. I just wanted to introduce you. You can add to this, but Tony is our Building Smart USA Education Committee lead. He does a lot of work with webinars. He's an excellent communicator. He's an idea generator. I was just thinking about you, Tony. And you write really cool visual emails that I always like. So thank you. And there he is. Nope, maybe can't see him. And he's going to talk about workforce development needs with openBIM.
So Trish, while we're waiting on Tony to get online and organized, I promised I would buy him a couple of minutes just to confirm that what we're going to describe to you in Tony's presentation is the training and professional certification. We heard in Aidan's presentation that Building Smart International provides this on a global basis. But on a global basis, there are national requirements. So we actually recruit training providers here in the US. We take the international training, which is, I think, 5 parts, and we add a 6th part, which is the US specific part, to the actual curriculum. So what we're going to do is describe what courses are currently available through the Building Smart US chapter. And this is another role of chapters. Remember, I explained the idea that Building Smart International creates the standard, and in this case, the content, the body of knowledge. And then chapters work with local training providers to be able to share that and implement that. But the examination is a Building Smart International examination and certification. So, Tony, have we got you online?
I am here. Are you seeing my screen?
Well, we're seeing a screen, and I'm going to give Janice a moment just to confirm that it's the right one.
Okay, well, we'll all know in a minute. Thank you, Ian. It has been my pleasure to serve with Building Smart since it was the International Alliance for Interoperability, for those of you who remember that. And it is especially my honor to serve now in this vibrant and impactful chapter with such insightful leadership. So huge thanks to all. And you should be seeing a Building Smart USA EdCom slide. Yes? No? Yes. Okay, great. Thank you. Well, greetings. Tony here. If my camera's not working, I'm this guy in the lower right. And we're going to do a quick update on behalf of the Education Committee. As you see, we're a large team with lots to do. We have representatives from academia, from government, from private industry, from around the country, and even Canada, thanks to Paul Woodard, who joins us. Here's the thing. All of these tools that we have are fabulous, and they're getting better and better with each tick of the clock. However, none of them work when people don't know what they're doing. And that's why we're here to help. So you know how to reach the chapter website. Here's a QR code. Note that Building Smart USA also holds international positions. We have an elected member to the PCERT steering committee at the international level, and we volunteered to review the BIM for Intra curriculum, which should be available any day now for review in the US in English. It was developed in Europe. And get ready, spoiler alert, at the end of this presentation, we're going to ask for people from federal highways, from all the DOTs, anybody with expertise to please help us review this curriculum and make it appropriate for use in the US. Okay, so when you go to the website, if you click on US committees, you can get down to the Education Committee. And from there, you'll find lots of activities. For example, webinars. Pay attention to those. You can use this QR code. We have upcoming webinars at the top of the list, and we've got topics planned through the spring of 2026, including some practical examples. Real-world teams present openBIM in action slides. We also have Min and Jeff with groundbreaking advances brought to us by our technical committee through a program they call Seeing is Believing. The webinars are always free. So if you see something that looks interesting, don't be afraid to click that registration button. Nothing bad can happen to you. But if you miss, you can go down to the on-demand section, find a topic that interests you, click on it. That will take you to our YouTube channel, and you'll be able to see all sorts of great videos. Just look at all of the videos that Janice, who's in the room with you right now, has already posted to that YouTube channel. We do record webinars. We are recording this event. The webinars do not include the casual chit chat and question and answer session. We do that for privacy, but all the presentations will be available. You can also have a look at the resource page, lots of different links to other websites and to our own materials, such as the newsletters. And yes, we offer certification training too. We have several training providers in the chapter, and they provide courses like the foundation you heard Aidan talk about. This is offered in the US, and with some special attention to US practice, it is at its core an international program. It's great stuff all on its own. However, it also unlocks the door to other kinds of education. Here in the US chapter, we've developed a special program leveraging openBIM for project management. It addresses the needs that people right here in the US face when they're using openBIM as opposed to just BIM for maybe their first or second project and want a little helping hand to know what's going to work and what might not work. We've also heard a lot about tools and how do we select which tools are going to be best for our project. Thanks to Dr. Min Sung, we have this wonderful program where you can not only hear an overview of different openBIM tools, but there are practical hands-on examples during this course. This is another course that's been developed specifically for our chapter. And for those who are thinking, yeah, but we get all that building stuff, what are you doing about infrastructure? The training providers here in the US understand that infrastructure is hugely important. So the curriculum, the training material that's provided, this is an example slide from a foundation course. You'll notice somebody understands that transportation exists. And when we talk about things like the importance of an asset information model to help manage built environment, we do understand and have practical examples for how transportation needs to use this technology and can benefit from it. And even to the point of when we ask you questions to make sure that you're understanding the material, we have questions that, although we also provide the right answer, we try to bring a little bit of levity into it. That's why it says someone with a Class B license. Folks that are DOTs, well, I don't know if you guys love it or not. You'll have to let us know. So here comes the pitch, my friends. We are now entertaining openBIM for infrastructure. It is an international program that was developed in the European chapters, is being translated into English, and will soon be available for us to review and modify. There's a new process happening at Building Smart at the international level that acknowledges Communities of practice are different from chapter to chapter, and they are giving us the grace of not having to create a new course all on our own, but being able to take this material that was developed through international collaboration and make it our own for the US. And what that means is we invite more participation. Federal highway folks, we know you're out there. DOTs. Janice, don't let them get out of the room. You have the capability to block their passage to lunch until they sign up, because we want this course, when it's released in the US chapter, to be one of the most valuable things we have ever done for education in the US, and that takes your help. So, thank you for letting me pitch you. Here's the email address that you can use to get in touch with us. We want to hear your voice. We want to do better than we've done before, and that requires collaboration. Also, if you're interested, the chapter is considering new courses and new certifications to be offered. We are engaged with the Professional Practitioner Program, which provides deep hands-on knowledge to people who need that kind of training. We're also elevating to the chapter level some other courses we know of that are available in the US on virtual design and construction, on collaboration science, on level of development, on consensus building. So when people are using interoperable tools, they can use them with facile hands and interoperable minds. With that, I think it's time to turn the session back over for questions and answers and let our great presenters see what folks in the audience have to say.